Okay, hello everybody. This is Mike here again. So I'm working on my continued series of videos, robotics, programming, learning, STEM, STEAM, STREAM with robotics, MicroBit, MakeCode, and programming. So this is like day 3 or 4 of the National Robotics Week here in the US. So this is my next series of videos that I'm doing it for this week. So this project is a little more complicated, but it's building on the steps that I've done before. I'm using the MicroBit to control a robot. You can see the screen over there. And the robot is DFRobot, DFRobot, the Maqueen Plus. I'm also using the DFRobot Gamepad with the MicroBit attached to it. And so basically, if you watch some of my previous videos, you connect one microbit to the other using Bluetooth or the radio commands. Same thing, Bluetooth radio commands. So I'm using this analog joystick or these digital buttons, and then values being transmitted through the microbit and its Bluetooth to the microbit down there, and then the robot bases its movements off of what I pressed on the gamepad. It's pretty cool. And I'm still using the microbit, but now I'm actually using the gamepad from DFRobot and Maqueen Plus, actually using it for something. So this code is a lot more complicated than some of my previous videos. So this may be a good opportunity. You could state so in the comments. This may be a good opportunity to start to create my own GitHub page for my programming classes, stuff I do with the microbit and other stuff, other programming or other robotics. So you can download the code instead of just watching it. Might make it easier. I don't know. We'll see. So again, let me grab it real fast. This is a Maqueen Plus. And I got the microbit connected and I got it turned on from DFRobot. Very cool little robot for under $100. And it's got a rechargeable battery, so it should last just sitting down there by itself. So again, let me share my screen, standard practice, and show you the MakeCode behind the programming. Hopefully it'll make sense. So like I said, I'm using MakeCode by Microsoft. It's so easy to program using MakeCode. I mean, this one was a little more complicated and took some effort, but once I figured it out, it was not that hard. So I've already done the programming. Let me just kind of show you what I did, and if there's enough demand, I'll start a GitHub page and post the code, make it easy on everybody. So the microbit simulation there on the upper left-hand corner, really not very helpful. So I'm going to just get rid of it for now. So this is the code that goes to the microbit for the gamepad. This is Gamepad 3.0 by DFRobot. So let's just start, kind of walk through it. So when the microbit starts up, there's an on and off button here in the front of the gamepad. It's got two AAA batteries. Wish they were rechargeable. Okay. So what I've done is on start, I show this icon. I'm just doing this icon. I change every time I do a code change. I change the icon. That way, when I download it, I make sure it gets downloaded, no issues. So I'm using, this is important, I'm using radio group 200. So both my gamepad and my robot, which I just knocked my phone down. So both my gamepad and my robot are using the same radio group, which is 200. Okay, that's important. You just got to make sure you're in the same little Bluetooth network you set up. Now, the buttons, the red, yellow, green, and blue buttons are all digital. So I'm pulling the pin value. And that's what on start this is. I'm setting the pull pin 13, 14, 15, and 16. Those are the 3 color buttons on front. I'm going to have them do something. No, maybe not all of them. I'll have them do something. So right now I got them setting to none. That way when I press the button, it'll know I've done something. Pretty simple. Just three sets of groups, different kinds of commands. The show icons out the basic menu. The radio set group is off of the radio buttons. And these set pull pins, that's go to advanced, see where it says pins. You get that from the pins. Oh, sorry, in the more section, I think. Set pull pin. This is in the more section underneath pins because I'm taking input from the different pin settings. Those are the digital ones, 13, 14, 15, 16. The joystick ones are P2, P1, and P8, and those are analog. And you'll see what I do with them down here. Okay. So this is what I'm saying. So I basically, I set up a forever loop for just a loop. You've seen these before. You've seen some of my other videos, just a forever loop, basically. So when I'm looping forever, this is the if statement, just one big if statement. Well, if and if statement nested inside the if statement. So on this one, this is not too hard, but basically what I'm doing is saying if the digital, it's reading the digital P16, which is one of those colored buttons. If it gets a 0 value, which is basically means it's pressed, then send through Bluetooth that radio send string LED left. I'm shortening it a little bit. LED L. And if it's P14 being pressed, then send a radio string LEDR. And you'll kind of see, if you see my previous videos, this makes more sense. But once I go to the robot code, it'll make even more sense. So if I'm not pressing the 2 digital buttons, I've only set up 2 of the digital buttons. If I'm not pressing those 2 digital buttons, then it drops down to the else. So it's looking for the analog joystick commands. And I set inside that else statement, I've set up an if, a nested if inside the else. And this is reading, and this is kind of more complicated, but this is trying to read the values being generated by the, let me see, I might have to make it a little bit smaller because you're not seeing everything. There we go. See if I can get all that in there so you can see what I'm doing. Okay, so the P2, it's like a graph. It sounds like sensors like a graph. So you got P2. This is the P2. Horizontal line is P2. And P1 is this line right here. So P2, P1, and P8's the pressing the joystick. That's making sense when you, this is registering, P2 is registering moving the joystick up and down. P2 is registering moving the joystick this way. P2, P1. Oh, that made sense. P2, P1. Basically like a graph. Now, it took me a while to get all these values figured out, but basically it's registering a value. I thought I was going to say, like it's like 1028. I think it's 1028. From 0 to 1028. Okay, so that's the values of getting kicked off by P1 or P2. Now, so what I'm saying here, I'm doing two things. I'm going to send a value F, B, L, R, and S. That's kind of makes sense. F means go forward, B means go backwards, L means to turn left, R means to turn right. So those are the four string values I'm sending. So I'm sending F, B, L, and R. And I'm sorry, and stop. F, B, L, R, and stop are the 5 string values I'm sending. Now, when I send 4 of the string values, I'm sending the value generated, the number value generated by the P2 or P1. Now, the reason why I'm doing that is I'm using that to modulate the speed. The higher the number, so the more I push the joystick one direction or the other, the faster it's going to go, either in this direction or this direction. So that's going to help me modulate not only the direction, but the speed. So I have speed and speed and direction modifiers. And basically what I'm saying for the P2s and for the P1s, basically I set up 3 AND conditions, and it just basically says when the numeric value being produced by P1 or P2 is greater than this value or less than 600, go forward. If it's less than 450, greater than 400, and less than 600, then move backward. Don't worry if this doesn't make any sense. I had to do a lot of playing around with it. I could probably spend a video explaining how I got all these values right. If I'm turning left, I want the value less than 450. This is off the P1 now, because you change. You look at the P2 values, then the P1 values. This way, we flip it. We look at the P1 value first. If it's less than 450, greater than 400 on the P2, and less than 600 on the P2, then I turn left, and then we kind of flip it. If the P1 value is greater than 550, and the P2 value is less than 400, and the P2 value is less than 600, then I turn right. So remember, when you do these conditionals, or gates and gates, all these conditions have to be true. So for this F statement here at the top, all these 3 conditions have to be true to turn forward, go forward, or send to forward with the P2 value for speed. And then if you go backwards, all 3 of these values have to be yes to go backwards, and all 3 of these values have to be yes to go left. All 3 of these values have to be correct to go right. Send right. And if you send nothing, basically you stop, you don't do anything. You said no value at all. And then that's, like I said, it's all nested in itself. I hope that made sense. It's a little complicated. Let's show the JavaScript. The JavaScript code may be a little simpler to understand. So all I'm doing here in the beginning is I'm setting my icon, my basic icon, and I must have changed it. That's not an X, it's a no, actually. It's maybe that is right. The radio group, set radio group to 200. So the first statement, I'm just setting the icon that displays on the MicroBit and the LED matrix. I'm setting my radio group to 200, and both devices have to have the same radio group to communicate. Then I'm pulling my pins. These are the digital pins, 13, 14, 15, 16. Those are these colored buttons. I'm just registering what value that you're getting at it. Then I'm just doing my basic forever function, just basically just loops, keeps going until an if statement happens, and then it does that if statement, and it just keeps going and keep going and keep going and keep going. Pretty simple. So if I press the P16, which is the blue button, then send LED L, which will turn on the left LED. If I press the yellow button or P14, then I want to turn on the right LED. And then if I'm not pressing the digital buttons, then it checks to see if I'm using analog joystick. And so basically it's reading the pins. And then it's checking to see what pin has a value. And right here, we're checking P2. And they're basically saying it's greater than 550. And means that's the AND gate. And then it's checking the value from the P1 and seeing if it's greater than 400. And then it's then checking P1 value again and seeing if it's less than 600. And if that's all three of those conditions are true, then the radio Bluetooth sends value F, sends a string F, and it also sends a number, and it reads the P2 number and sends the P2 number. And then we just kind of repeat with a little changes for each of these SLs. We read the P2 button first, check its condition. Then read the P1 button, make sure it's greater than 400 and less than 600. And if that is true, then it sends a B text value and a number for the P2, which is up and down value, which is Y. Sorry. Then it drops to the next SL. So what it's just saying is it just spins through these two ifs, this nested if, the if and the nested if, to see if these values are true, and then it does something. And then if when it's pulling pin 1 and pin 2, it meets these three conditions, then it sends the text of L and the P1 value. And the next else if is read the P1 and P2 values, and if it meets these three conditions, then you send a text of R and the P1 value. If you get nothing, then basically you send an S, which means for the robot not to move. The other four are for the robot to try to move its wheels, either forward, backwards, left, right. And when it's going left, I'm just actually slowing down the left wheel, speeding up the right wheel for it to turn left. And in the opposite, if I wanted to turn right, I slow down the right wheel and speed up the left wheel, and that way it turns right. I hope this is making sense, but that's pretty much what I've done. These values, like I said, I had to play around with them to get them to work, but at least they work for me now. Okay. Now we're going to show you the code for the robot. And okay, here's on start. So let's do the on start first. I'm just doing the icon solely for me to do versioning control to make sure that I have my latest version on the robot. Then you set the radio group to 200. Whatever number you set it to, 1 through 255, needs to be both for both of your microbits for them to communicate, set up the little network environment. And with the gamepad, it doesn't look like the gamepad is designed to have an individual number in the radio group. It must do that automatically, because I don't think you can control multiple robots, DFRobots using the same gamepad. I could try that out to see if I can do that, but it probably doesn't make a lot of sense to try to control 2 robots with the same gamepad. And I can always try that, experiment with that, and see if I get that to work, just as a informational, something informational. But at least for this thing, the 2 Bluetooths know the difference. One knows it's in the gamepad, and one knows it's in the robot. It must be all happening behind the scenes. So I'm not setting individual value for each microbit. Okay. Now, so I had set up 2 different ways to do this. So on radio received, I'm receiving a string. You'll see why I had to do this after I show you both codes. So on radio received string, I'm basically taking the digital values. So if if I receive a string, and that's because I pressed one of the 4 colored buttons on the joystick, then if it receives LEDL, that means it turn on the left LED and turn it on the red. If I press I always change the colors here, but if I just press the blue button, then it'll turn on the right LED red. So just I can toggle the LEDs. Else, if I don't receive, if it doesn't receive a string, then it just turns the colors off and stops the motors. So that's on radio received string. And I'm doing that for the digital values key press. Now, this is a little more complicated. Let's see if I can show you most of the code. Can show you most of it. Let me walk through it. So this is a little bit different. I don't know if I've shown this command before. On radio received name and value, you'll see why I did this here. But on radio command, send name, a straight piece of code there, on name and value. So inside this on radio received name and value, so basically you're passing 2 values in, both a text and a number. Name is the text, value is the number. So inside here I put an if else. So if name is equal to F, which means you want the robot to go forward, then motor all, direction forward, makes sense so far, speed, and this is where I'm getting the value. Map the value from low 555, high 1023 to low 10, high 255. This is just a way to map the value and get the motor to correctly move based on your joystick, analog joystick input. You're probably going to ask where I got those. I got that in the map menu. In the map menu from low to high to low to high. And that's where I got the purple. And the green, the motor is, where'd it go? It's actually from the Maqueen Plus. So let me show that again. So whenever you're using the Maqueen Plus, you need to download their extensions. And I've already done this, but to get the Maqueen Plus to work, you got to download their command extensions. And I don't want to press on either one of these, but since I have the Maqueen Plus, I use the Maqueen Plus extensions. If you got just the regular Maqueen Lite, then you use the Maqueen Lite. But I've already done that. I've already imported those extensions. And that's where I got the motor. Motor, you can do motor stop. There's where the motor stop is. You can read the motors, motor left and direction and the speed. There's all kinds of really cool commands that you can get information. This is where I got to set the colors. So when I'm setting the colors up here and the ready to receive, that's where I got those colors from. I got them from the Maqueen Plus menu. They also have Maqueen IR, so you have an IR controller. Okay, hopefully this is making sense. So, because I'm getting two values in when I'm doing the analog, I'm doing both text value, F, B, L, R, and S, and I'm doing an input value, either the P1 or P2 values. So if I send an F text value, I want it to go forward, and then I'm trying to map out the speeds to give it a variable speed, depending on how far I push the joystick forward or back. And if I send a B text value in the name, then I want to go backwards, and these are the values that I'm checking low, high to low, high values. And this value is then being used as the speed of the motor. So left is a little bit different. I'm using 2 because I'm having the right motor be different than the left motor when I'm turning left, and you'll see, because you want it to go this way. So the left motor, I slow it down, and I speed up the right motor based on how far I've pushed the joystick. Sorry, left. And I'm just increasing the speed of the right motor to get it to veer left, and decreasing the speed of the left motor. And I'm mapping that value to the value that coming back from the P1 value. Hoping this makes sense. And just kind of repeat. These are all just repeats of each other except for the left and right. And then on the right, I'm doing exactly the opposite, which I did for the left. I'm increasing the speed of the left motor, decreasing the speed of the right motor to get the robot to turn that direction. And it's also judging the speed on how far I move the analog joystick this direction, opposite of what the left-hand turn was. All the code's basically the same. I'm just mapping the value, the number value I got from the P1 or P2 from the analog joystick. Then it's kind of a catch-all. If I do nothing, if I send nothing to the robot, I want to turn off the RGBs, the LEDs in the front, stop the motors. So that way I just want so what I'm trying to do is I'm trying to keep the robot from continuously just keep moving. If I'm not doing anything, if I'm not pressing the joystick at all, I don't want the robot to move. You can see down there, the robot's not moving, then both are on. Then I have a catch-all, which is basically if none of these ifs or elses conditions happen, the comparisons happen, then also you don't want the motor to move. Just kind of a catch-all. So that is the code I downloaded to the robot. We can go through the JavaScript code real fast. So on the set, here's the set down here. Set the icon to yes, the radio group to 200. Again, your radio groups have to be the same for MicroBits to connect to each other on Bluetooth. This is the digital code. So if you received string, you basically call the receive string function, and you check. I'm checking the value I sent, the text value I sent, LED or LEDR, LEDL or LEDR. And if that's the case, then I set the RGB light on the front of the robot to red, or I set the RGB light on the front of the robot, the right-hand side robot, to red. So I just flash either one of the LEDs on front of the robot. The cool thing is you can set it to lots of different colors. One, I'm just using red for this example. And else, if I don't do anything, then turn off the RGBs, both of them, and turn off the motors. Don't have the robot do anything. So this may be a little simpler to see. So this is the analog joystick commands. And basically I'm saying on receive value, pass into the function both a name and a value. So send in the name, which is a text value, and the value, which is a number. And then check the name. Check the name first. If the name is F, that means then I check the value. And if the value meets all three, this is actually a lot simpler. So I'm basically saying, so I'm using the libraries from the Robot Maqueen Plus, and I'm running the motor, and I'm passing it in both motors. So this is where you get the motors all. So I'm passing in a value to the motors method, and it's all, and the direction, and then here's the math. And the math is saying, it's a lot more condensed. I'm mapping these values. It's basically saying, oh, so it's saying this is the high value, this is the low, this is the, well, let me do that again. So it just basically gives a value range. So you pass in the value as a number from low, from high. So the first value you pass in is from low, the second is from high, and then I do the opposite, too low, too high. So it doesn't have, actually, just, this is a cool way to condense all those ands into a small, simple statement. So when I map these values in the math function, it's allowing me to have a simpler way to do these comparisons really quickly. And just, and, oh, I'm sorry. Yeah, you're just saying if, yeah, these values here. And then for B, if I send in B, I send in these values. I do a value check to make sure that that value I'm passing in, the value I'm passing in is within these parameters. And the same thing for front, back, left text value. Now, as again, there's motor 2 and motor 1. And is that the right motor? Let's check that. Yeah, the map value just looks like what it's doing is making sure I'm not passing in a value too high or too low for the motors. And then looks like the right motor is M2, the left motor is M1. And I'm just using the map value, the map, that map string, or not that map function call, just to make sure my values aren't out of range for the motor, so I don't burn the motor out or damage the motor. So on left, this is the left motor, this is the right motor, and then I'm calling the Maqueen Plus library and functions, methods, pass it in the what motor I want and what direction. So I'm passing in three values: motor, direction, or motor all, motors, direction, motor all, clockwise or counterclockwise, and speed into the motor run method. And on the right, it just basically kind of flipped it on a right text value. I'm checking to make sure that the motor value is not out of range, because you probably can't get an out of range value when using this analog joystick. And if you do, you don't want to burn the motors out. And having it turn right by increasing the speed of the left-hand motor. And then on stop, if I'm setting a text value stop, I'm basically just canceling everything, turning everything off. The two RGBs on the front, I turn both RGBs off and turn the motors both. I'm not setting all, because I'm not setting the value, because I'm just saying all, but I'm not saying clockwise or counterclockwise or motor speed. It basically just turns the motors off. You just pass in one value. And then I have my drop down catch-all, which is basically just turn all motors off. And it's the same thing. It's calling this motor stop method with inside the Maqueen Plus libraries, classes, calling this method and saying all, which is both motors. And I'm, like I said, because it's both motors and I'm not passing in a value, not passing clockwise or counterclockwise, it's just motor off. All right. That makes sense to me, but it may not make sense to a lot of people. So pretty straightforward. I mean, it's kind of complicated, but when you try to break it down and you see that there's a lot of repeats and just opposites each other. Forward is opposite of back, back is opposite of forward, left is opposite of right, right is opposite of left. So you're doing some of the similar things, but you're just flipping them polarity because they're opposites. Okay. I think that's basically all the code. And I think you saw where I got all the code. It's pretty simple. You just got to get the Maqueen Plus extensions if you're using the Maqueen Plus, and that allows you to control the motors. The Gamepad, I didn't really have to use any extensions for the Gamepad, which was cool. And I was using radio buttons, which is basically Bluetooth, and I was using the pins, these pin values in the Moors. So I'm just drawing pin values. I don't think these are specific to the Maqueen Plus, but there is some I2C stuff, which is on the Maqueen Plus. Maqueen Plus has pins, both digital and analog pins, and I2C pins, so you can read that values and analog values and so on. SPI, I'm not sure what SPI is. This could be added by the Maqueen Plus. I could always check that later and see. But you definitely need analog digital pin pulls and I2C pulls for the Maqueen Plus robot platform, because it has those connections on there. So let's just show you the robot in action. So I've downloaded the code, I've tested the code. So I got the joystick is on and the robot's on. I'm pressing the analog button forward. It's not a bad speed. I'm kind of impressed by the speed of the motors. And this is carpet. That was backward on the joystick. I'm slowly pushing the joystick forward. So you can see I'm getting a little variation in the speed based on how far I pull back or pull forward the joystick. I'm getting a little variation of speed, not great, but I'm definitely getting a variation of speed. Okay, so now I'm going to push the joystick right. And I am getting a little bit of variation in speed, which is awesome, which is what I want. It's not perfect, but these are not really expensive servos. So, and this is carpet. This not, yeah, there we go. It's kind of getting stuck on the carpet. So this is pushing the joystick all the way to the left to make a left-hand turn, and then right to make a right-hand turn. Let me see if I can show you. Kind of hard to see, but I'm going to press. So that was the right or the yellow button. I'm just holding the button on the gamepad, and you can see it's actually red. Kind of hard to see it, but it's actually red. And I'm pressing the blue button, and I'm getting the other LED to work. Let's bring that up. Because I can map more values to the joystick and have the joystick do more things. Because I got the A and the B button, so I can do A or B or press both at the same time. It's like there's a microphone on here too, so I can have it make a noise. Maybe even accept commands. So here's the analog joystick. So I can actually have it do something if I press down on it. So I could map that, and that's P8. The buttons on the side are are digital P15, 16, 14, and 13. 16, 14, 15, 13. So I can add some different functionality to the robot. Okay, so if I press this yellow button, so you can see it turns red. The cool thing about these RGBs is you can do different colors on that. I think there's like 5 or 6 colors you could have it do. So based on the command you press in, you can change the color to make it easier to diagnose stuff. And then there's the left RGB, right RGB, left RGB. And then I can map it probably to do other things with the AB button. So that's about it. I think this I'm kind of happy with this project. It took me a few days to figure out these all the analog, how to read the P1 and P2, P1 and P2 values. You can see it's a little graph on the X, Y, and X. So P2 is Y, X is P1 value, and there's no negative values. It's 1 through 123, I think. I'll have to check that. There's your on and off switch. Double A's. This P0, I think it's like a little speaker. I'm not sure what P12 is. I'll have to read that. And you also have the A and B buttons, so you don't have to touch the MicroBit, and you can display values and stuff on the keypad and our LED matrix. So it's a pretty cool little gamepad for under 20 bucks, and you can make it with both the Maqueen Plus and the Maqueen Lite. So I'm very happy. I'm very happy with so far with the MicroBit and how easy it is to use, how easy to use the MakeCode. And it's really cool that Maqueen and the Gamepad, mostly I can still use MakeCode with both of them because I just download the extensions and I can control all the motors. They're kind of hard to see. You probably can't see them, but because it's not going to focus very well. But so I basically have these are the digital values: 15, 14, 13, 12, 8, 2, 1, and 0. I think digital is 15, 14, 13, 12. And I think P8. I'll have to check that. Charge the battery here, on and off switch. This actually has, so green is power. Here, 3-volt battery is the red in the middle, and ground is the black on top. I think this is I2C down here. VCC, ground, SCL, SDA. Yeah, that's I2C right there. That's your I2C connections. And you've got 3 volts, ground, SCL, and SDA for your I2C. And then the P14 through P0 have your ground, 3 volts. And P, which is just the pin number. You can pull the pin value. And then these may be the digital. This is ground, VCC, and signal. You got S1, S2, S3. It's a very cool little robot for the price. So I have Maqueen Plus version 1 by DFRobot. And it also has line following sensors here, which is cool. It has 4, 5, 6. All right, very cool. I kind of rambled on and on. So, Alexa, but I really like this platform, and I think it's a great way. I find this easier to teach the MicroBit and the DFRobot Maqueen and stuff. These are well made. There's lots of really cool tutorials and stuff online on how to do stuff. The mapping, the analog joystick was a little complicated. I got a little confused. It just took some trial and error and some practice to get the values correctly. But once I got the values figured out, that they're 1 through what I think is 1 through 1023, and I kind of mapped them out as far as what the middle line was, the non-moving, then back and forth, what those values would get me. Then I kind of got it figured out. So cool. I hope you found this informative, interesting. If you have any questions, don't understand something, whatever, just feel free to put a question in the comments, and I'll try to get back. I'll try to answer it as best as I can. Like I said, if there's enough demand, I could start a GitHub page to put all my programs out there so people can download them and just don't have to type them in, by hand. But I think, at least I think, if you watch the videos, maybe pause them, I think you will learn something if you actually type and drag and drop and do a block code. If you do it, you'll learn better than just copying and pasting what I did. But that's just me. I think you'll learn more by doing it manually instead of copying. But whatever, we'll see. We'll see what the comments are. So once again, thanks for watching. I hope you found this video informative. I hope you see you in the next video. And cool. Thanks for watching. Hope to see you again. Bye.